Okay, let's try this example. It says determine the stronger acid in each set. So the first thing that I notice is I have entirely binary acids. H is simply attached to one other nonmetal atom. HF, HBr, H3AS, H2SE, H3P, H3AS. We don't have any oxygens. This is not an oxy acid. So when we're determining strength, we need to look at where the element that's attached to hydrogen, where those two elements that we're looking at are positioned on the periodic table. Are they positioned left to right along a row on the periodic table? If so, we want to examine the electronegativity of that element attached to hydrogen. If they're situated up and down in the same group or column on the periodic table, we want to choose the element who's larger. The bigger the atom attached to hydrogen is, the weaker that bond becomes, and the more easily H plus is allowed to leave. Let's look at our first set. We have HF and HBr. When we compare the two elements, F and Br, we notice that they're both halogens in the same group or column on the periodic table. When comparing acids whose element X is in the same family, that acid gets stronger as we go down a column or a group on the periodic table. And again, this is because Br is a larger atom than fluorine is. That bond between H and Br is a weaker bond. It allows H to leave a little bit easier, making a stronger acid. Now let's look at example B. We have H3AS and H2SE. So we're going to compare the positions of arsenic and selenium. When we do that, we notice that they are in the same row or period on the periodic table. When comparing two elements along the same period, we know that acid strength will get stronger as we go from left to right on the periodic table. This is because of electronegativity. We're going to choose the acid H2SE because selenium is a more electronegative atom than arsenic. It pulls electron density away from hydrogen more than the arsenic atom does. Now, our last example is H3P and H3AS. We need to compare the positions of the phosphorus and the arsenic atom that's attached to our hydrogen. When we look at those positions, we notice that phosphorus and arsenic are both located in the same column on the periodic table. For binary acids, when we are comparing H attached to an element up and down on the periodic table, acids get stronger as that element X becomes larger. So we're going to go ahead and choose the H3AS molecule as our stronger acid. I hope that helps. Take care.